Hi there, my name's Doug Milburn. I'm president and I'm co-founder of 45 Drives. Here in front of the camera again, after I just recently did a video on ransomware, which ran and got lots of views on it so far. Incredibly interesting topic. I wanted to go back. We're talking inside about things every now and then. I get excited about something and I ask our video crew here and like Joe over here, and I say, Joe, can I do another video? And they reluctantly, for some reason, they say yes. I don't know what it is, but I get to do another video. Anyway, I want to talk to something seriously. I'm really, really passionate about this. There is a decision that comes when anybody's considering serious storage. Do we use single server, like this baby I have here, my 60 drive storinator, or do I put a cluster together? So cluster, I'm tying together multiple servers into a cluster via my network and clustering software. Two approaches that can store big data. What's the right one for you? And so the answer to that is it depends, like everything in the computer world. I'm going to declare my bias right now, though. I'm a lover of clusters. Why am I a lover of clusters? I don't know why I'm a lover of clusters. I don't know. They got this infinite expandability. They can just become high performance beasts. I'm a technical geek at heart. My background in three university degrees, 2 in physics, 1 in engineering. And I have always loved all things technical, and it could go from airplanes to boats to large diesel engines and machinery. Okay, I love that stuff. I love computers. I love high performance computers. I love big data storage computers. Clustering seems to feed that love. So I got a bias. So you can interpret what I say in that bias. I'm going to declare it. It's good to understand your biases. We all have to think through our biases. But what I'm going to do here is I'm going to try to say something that's really useful to you. If you're looking at putting big storage in, that big thing, do I go for a single server or do I go for a cluster? So let's go over this. And I'll tell you, the other thing that I'm going to do in this video is I'm going to go over an example in this. I'm going to go over the criteria, and then I'm going to go over an example. I'm going to use our company as an example of this. Okay, so let's get started on this. So when I'm done going over the criteria, I'm going to go over an example. Okay, as an example, yeah, I have my role in this company and what we sell and what we do for customers, but I also have a role. I'm a buyer of networking equipment and network and storage, and we use storage like every other organization. If we don't have storage, you don't have a computer network, and you're not in business today. So I'll talk a little bit about our network. My experience with our network, when we started this company years ago, I actually built our first network and our second network and our third network, and the first one was coax, just to date myself. So it was coax network, 10 megabit, I do believe, which was smoking fast in the day. We've come a long way. We have professionals that do that right now, not a generalist like myself. And but anyway, that perspective's in there, and that architecture or network is something that I'm just excited when they are kind enough to allow me to poke my nose in and kind of live vicariously through them. So we'll talk about that network. Oh, by the way, that network now has, we estimate around 600 devices on it that would have an IP in that network. So it's significant, and I'm going to talk all about our storage needs and why we run on a cluster. We're in that zone, really most interesting zone, and form the subject of this video. There's some places that are obviously cluster. There are other places that are pretty much no-brainer to go single server. And then it's a big zone in the middle where you can go either. And we'll talk about your decisions, what's important to you, and why you would choose cluster or whether you choose single server. Okay, so let's talk about the first criterion here. And that criterion is how much data. That obviously has some kind of influence on whether we go with a cluster or whether we go with a single server. Okay, so, and before I try to make something simple out of this, I'd have to say it's not really all that simple. Why is it not simple? Because when you buy data storage today, you need to think about data security. Critical part about what we do. Everything we do, data security is designed into everything we do. Why? Because everybody we sell to, we don't have anybody who buys data storage, but their data is not important. As I said in my ransomware video, you can lose everything in your network. Good. Put an insurance claim in. If you probably have insurance, get all your gear, buy new gear, and just reconfigure it and put your software back on. You're up and going, right? Almost. If I don't have my data, I'm in big trouble usually. Very few exceptions. Sometimes I'm dead in the water. Sometimes my business is just going to close, or my government organization can't function, or whatever else. Okay, so data security ties into this, into size. Why does it tie into size? Because data security, all the ways that we create more security for our data, also use up storage to some degree. There's some pretty efficient ways to do it, but there's always a cost to security. Fortunately, incremental. So when I talk about size of my storage needs, how many terabytes or petabytes of data I need, my first question is how much data do I have? And I got to factor in growth. We're going to talk about growth separately, but when we factor in growth and you figure out your near-term storage needs, that's your first step in this. So where do I move from there? I go, okay, now I need security. So my security comes from, well, it always costs me somewhat in terms of more storage required. Okay, and it's an incremental cost, and it's a cost everybody should pay, well, unless your data is not of value. Okay, so you can figure it out, and you can figure out your level, how much security you want. You're going to have to burn up storage space to make yourself more secure. Okay, so let's talk about that. I have my amount of data that I need, and let's think about it by peril that I'm trying to secure against. Okay. First peril I need to secure against is loss of a hard drive, be it spinner or SSD. You lose those things, or just the data on them just gets corrupted every now and then. They're pretty darn reliable, but we want our data to be around forever. Okay. So the first thing we do is redundancy. So the word RAID array, a redundant array of inexpensive devices. Okay. So if I want to store, and let's talk about 20 terabytes. So we're in the big data world. Let's talk about 20 terabyte hard drives. So you can think about how many 20 terabytes. So you can think about 14. I just asked our crew where the economical point is, and they really think it's around 14 terabytes for a spinner. If you want economical, we're not talking about SSDs yet. That's performance. So you talk about that. So you look at that and you go, yeah, we got to add more drives. So what do? We put drives in arrays, and we put extra drives in there, and we use the magic of parity. You can use mirroring, but I'd suggest parity is a better way to go for certain reasons for most applications. And we put in extra drives, and we can survive if any one of our drives dies. Good. We pull out the offending drive, and we plug in a new one. Send it back to 45 drives so you bought it from for warranty replacement. If you bought an enterprise drive, you got 5 years on it. Beautiful. We're good. That's our first level. What's our next level? Well, what happens if we have some kind of system failure? We could have a file system gets corrupted. That's pretty rare, but your file system could get messed up for some strange reason, and you really want to secure against that. Something zaps inside that data set. Well, your next level that you want to do is you want to create backup sets. And the next level is a backup set on server or on cluster. Okay? Why? As soon as you get a lot of data, it takes a lot of time to write it out through even the fastest networks. When you work it out, and when you're into many hundreds of terabytes or into petabytes, and you look at how long it takes to go down a 10 gigabit network, let alone if you have 1 gigabit network, it's going to take forever. 10 gigabit, and even get to 100 gigabit networking, and it's still taking a long time to push a petabyte out of there. So doing a full backup, there's moving a full backup out and blowing it down the line, that takes a long time. So backups, and again, totally separate video, we'll talk about that whole broad data security scheme, but you want to back up, and backing up, your first line is backing up within your server. Great. Next peril, meteorites. Just kidding. But anything, we use meteorites as our metaphor for anything that might just come in and destroy your server and smash all your hard drives. You could have a fire in a server room or something like that. How do you protect against that? That is the point where you go and take one of your on-server backups and you write it down the line. You take the time every now and then periodically You're going to shove that down a line and you're going to send it onto a backup device and write a whole new set, fresh set, just in case there's anything wrong with the last set. Okay? So you're going to do that once in a while. And oh yeah, we can push incremental backups down the line too. That's quicker and easier depending on your rate of data accumulation. So there we go. We got a few different levels. What about my next peril? My next peril is accidental or intentional data deletion. So we look at that and we go, well, how do we protect against that? And the other one that rolls in with that is ransomware. I talked about that in a video last week. Snapshotting is your solution, and really common snapshotting. So we've got all these things take up room. I'm going to go over an example and we're going to talk about that and tell them how much room it takes. So what I got to do before I plot out what storage device I'm going to buy and whether I take cluster approach or whether I take single server approach, I need to figure out my total data storage needs. I can figure in what we call raw storage capacity. Okay? I'll have my actual data size done, inflated by redundancy, inflated by backups, and inflated by snapshots. Okay? That's your full needs, that's your real needs. Take that and allow for growth, and then you got the size, the raw storage capacity that you need to develop for whatever way you're going to store it. Okay, so we look at the criterion of size. It comes down to how much data I have, and I got to inflate that. So that's my actual amount of secure storage that I want. I have to inflate that by everything I talked about, and to figure out how much raw storage. So the server size, the server capacity, okay, which is the number of bays times the hard drive sizes, that's the actual number of amount of raw capacity that I have. So if my data set times the inflation factor is in a size that will fit on one server, okay, then I can use a single server for the job. Again, also I can obviously use a cluster. Okay, how much is that? Well, really simple. From anything, the smallest data set can fit on a single server. And what's the upper limit of a data set that would go on a single server? Let's look at this beastie over here. This is our 60 drive unit. Take a 60 drive unit, plug 20 terabyte hard drives in it. You have 1.2 petabytes. That's a lot of raw space. Your data security, we look at it and I think, ballpark a factor of 4, maybe if you want to be really secure, maybe a factor of 2 if you're okay being less secure. Then we can take then we can put everything on a single server. Okay, so size factor. It's too big, has to go in a cluster? No, if it gets too big, you can use multiple single servers. And there are cases when you'd want to do that. Let me talk about why you wouldn't want to do that first. And this is why we don't use single servers. Okay? Because you get into something, we call it server zoo. Think about server zoo. What's a server zoo? I don't know. The organization that you happen to work for, if you're an IT professional, you might well have a server zoo. What's a server zoo? Well, back in 1999, we bought an HP server that's this big and we store whatever on it. We outgrew our capacity of that in 2004 and we bought another server and it was a big beastie and we loved it at the time. Then we filled that up, but we left all the data on there. And then we moved along. I'm kind of exaggerating with the 1990s, but it could be that far back. So you end up with a zoo of servers. Okay, what's the problem with that? Well, nothing really. The old ones are slow, but if it's doing the job for you, that's okay. But you've got a bunch of machines. Your data is on a bunch of machines. If any one of those machines go down, you don't have high availability. You'll lose access to that. Well, that's okay if on a single server anyway, that happens. But you get into multiple namespaces. And what happens from a user point of view, they may be looking for a particular file. And then they got to go, well, which server is that file on? Okay, and which namespace. So anyway, it gets into a zoo and keeping track of everything, and it gets hard on your users. Okay. Clusters are a great solution around solving the problem of server zoo. So server zoo is something that will move you towards clusters. Okay, let's talk about another criterion. Okay, growth. Some organizations have data sets, and these are really in the minority of the people who come talk to us, but they come talk to us because we're about big storage. But every now and then we get people that have some pretty static sized data sets. You have a static sized data set, there's an argument that says I can put that on a single server. It can sit on a server on its own. I can size the server up big enough to take in all reasonable growth. Okay, then there's the rest of the world. Okay, data storage is, data's getting bigger and bigger and bigger. Our storage has to get bigger and bigger with it. Okay, problems. Okay, if you go for a single server strategy, you end up with a server zoo issue. Okay, and even if even if your data set is small enough to put on a single server, if it grows and you get bigger than the size, I got to get another server. Okay, or if I start off and I say I can use 2 single servers, well, I'm split into 2 namespaces. Things grow, you're going to get 3 namespaces, 3 servers, 3 names, minimum 3 namespaces, 4, 5, 6, and after a while, your users. And they go, well, where's that data? Oh, it's on the other server. Oh, it's over there. Let me search. And then you got to go and search multiple servers, and it really becomes a pain in the butt. That's what clustering, that's the primary thing that clustering solves. It takes all your physical servers and puts them into one giant storage pool. And out of that pool, you can create the namespaces that your users see. So that's why it's called software-defined storage. It's a beautiful answer to that. So think about that when you think about your architecture and what you want to do in storage. Is Server Zoo okay? Okay. Is Server Zoo going to be a problem for you? And an awful lot of people that listen to this video, if you're an IT professional, you probably have a Server Zoo issue in your organization. Most organizations have Server Zoo problems. So let's talk about the other issue, another issue. Okay, so it's availability. So if I have single servers, I get a server zoo, I get one server has a certain chunk of data on it, or set of data on it, another one has another set of data, another one has another set of data. If any one of those servers goes down, which is going to happen, it may be unplanned that it goes down. Maybe it's planned because maybe you just got to do maintenance on it, right? And if any one of those goes down, your users lose access to it. And you can hear them in the background. They're squawking from out in the cubicle land and all the offices. And you hear the squawking, hey, did that server down? And you go, yeah, anyway, there's a problem, right? So your organization, where are you as an organization? What level is having your data available at any one time important to you? And there's some really interesting, when you dig into that, and I look through our clientele, and I look into that, and I look at people that, there's some surprising areas. I mean, as soon as any business gets big, you get a group in our organization. We're almost 400 people at this point in our organization, and we got our main storage server goes down, and you see the groundhogs popping up out of the cubicles. We did a video on that ages ago, and it was great fun. And we actually put it out as a Google ad or as a YouTube ad, and it's like you can just see the head pop. Hey, is the server down? Server down. And then the next thing you know, and it's real. You'll hear this dull roar starts. And as everybody pops up and stops working. And meanwhile, you'll see IT will be under enormous stress because the whole place is disrupted. You go. So that's because single servers do not offer what we call high availability. Let's go over to a cluster. In contrast, the beauty of clusters, we take our data, we set up a cluster. The elegance of clustering. We take a minimum 3 servers. It just gets better as you add more, you expand it, and you add more servers. The performance gets better and the availability gets better as you do that. You set up your redundancy. So typically if we put 3 servers in, we would do what's called erasure coding. It's like RAID, except we do it at server level. So your data gets split up into everything gets split up into 3 chunks. Any one of them can get lost and everything keeps on running. So server goes down, no problem. Coming in at night for maintenance, don't need to do it. No more weekends given up to come in and do maintenance on the server, because you can just pull a server down and you can do your maintenance and you can put that server back up. Okay. Unplanned service outages. It's like, server outage? Yeah, okay, I'll get to that. Let me finish my lunch. The beauty of that, the elegance of that. It's absolutely beautiful. And you think organizations, the one example I talk about, general file survey in a company that has a lot of people. You think if you were doing a retail. So we have a retail customer that at stores, and it's not a huge data set, but in this retail store, they need their data server goes down, they're shut down. It doesn't work. Their commerce, their self-checkouts and other checkouts don't work properly when they do that, okay? I mean, they got other, they lose their internet and whatever else. They're losing their bank cards and credit cards and everything else, but they lose their data server. they got a problem. So when they can move to clustering small data sets, their cluster would look something like this. There'd be 3 1U servers. The premium for going to a cluster for the same amount of data, so the main difference is in the price of the servers. 3 of these, okay, for 12 bays versus an AV15 single server approach. Single server approach would save you about $3,000. So you can think of what 3,000 means in terms of your projects and what that means in terms of insurance of uptime. So, and again, it's totally up to your use case, your budget, etc. But high availability is not a large premium. And like I say, everything that comes with that in cluster. My bias, I love cluster. I totally get it that our IT crew that, as I said, server down, cluster, no worries, let me finish my lunch versus panic. So another criteria, performance. It depends, do you need performance? This is a high performance storage application. Performance, we talk about speed to get data in and data out. There's a bunch of things to that. Is it small file? Is it large file? Well, it's not so much a cluster single server issue as do we go to small file, we want to move to SSDs for small file. Big file, big data, spinners just win everywhere on that. So, but when we talk about actual, and throughput, clusters got this beautiful scalability that just the bigger the clusters get, the more you distribute it out, your performance, throughput, overall throughput performance can scale, but you can do pretty good in single servers. You can pretty much, I can't say anything as a rule on that, but there is one place that I will give single server the advantage. Yeah, it hurts me. I love clusters, but it hurts me to give them an advantage, but they really do have an advantage there. It's single client transfer. You can get faster single client transfers out of a Linux ZFS on Linux single server. Okay, and we can tune it up. What can you get to? I don't want to put anything out hard and fast because most of the time we get into tuning 10 gigabit networking limits on the client end for sure. Some people have backbones that are larger, but most of what we do, 10 gigabits is the limit. If it's 1 gigabit, everything runs fast enough to saturate your network. You can easily take a single server ZFS machine and saturate in a single client transfer. That's harder to do in a cluster, but not many people need that because when you're saturating 10 gigabit, you're faster than an internal NVMe SSD drive. So you're awfully fast for it, and most clients can't even handle that. Your software end can't handle it. But if you need it, it's the place to go. Single server is the place to go. And so my last comment on criteria, and this is not a criterion on itself. There's a word, it's a summary of it. There's a word we use around here, and it's called elasticity. Okay, single servers have a rigidity relative to clusters which have elasticity. Okay, we love those words. They really say what we mean on it. So here's the difference between single server. Okay, single server, you set it up. It's got ZFS. You can put it into one big storage pool with multiple arrays in it and whatever else. But you set that up. It's that size. That's it. You grow beyond that, and getting bigger is just difficult. You bop into the namespace problem, and you want to shrink down and move things elsewhere, and you want to slide stuff around. You got one storage space, and you want to roll that into something else. Yeah, you can figure out how to do it, and it's there, and a talented IT team can do a bunch of amazing things. But in cluster, it's this simple. You start off with 3 machines. You want more space? Plug another machine into your network. Flip it into the array, into your hardware array. Okay, tell it you got another server. The data in the other storage servers drains down, and it drains and starts filling up the other one. You now have a 4-machine cluster. That's it. Hardware layer, totally disconnected. Yank the plug on a machine. Good. It's all right. It self-heals. It's so cool. Elasticity in your user space. You get one storage namespace grows and another one shrinks. It's all in the same space. It's all software defined. It's just elastic. Things can grow and shrink the way that they need to, and you just end up not having to worry about it. And it's just so nice. It's a path for, well, as long as the storage paradigm we're in lasts, your cluster is your solution you need. It's going to take you there. It's going to take you there forever. Okay, let's get the last part of this video. This video has been a little longer than I usually like to do our videos, but I love the topic. Hope you did too. Hope you're following along still. Let me give you an example. I promised you I'm going to take you over our network and our company. So our network and our company has grown to a point now has 600 devices. It's got 10 gigabit backbone managed switches, good quality enterprise grade switches, and we got tons of storage on it. But our core storage for the company, we made the decision to go with a cluster. Let me talk about why we went with a cluster in the context of everything I said, and I'm just going to give you an order of magnitude for size here, and I'm just going to go through this really quickly. And if you don't mind, I'm going to turn over here and I'm going to use my whiteboard because I love whiteboards. Actually, everybody in the company, when they're around me, they just have to put up with me writing on whiteboards, and whether it's useful or not, I don't know. But let's talk about this. So amount of data we have. So data volume size itself. We have something under 10 terabytes of company data. That's all our customer files forever in 2 divisions. One of them has a lot of CAD files and images and things like that. It's got our accounting on it. It's got our HR files. It's got all our user files, all our product development people's CAD files and everything else. So that is in 10 terabytes. Actually, I'm just going to use a less than sign on that if you don't mind. Okay. We also have, I got Joe, our videographer here, standing over there. These guys are data hogs. Joe, you guys are just terrible. You're absolutely terrible. So these guys, we do lots of video. We love communicating video. It's fun. We got about 30 terabytes of video. We consider everything to be important. We don't want to lose any of it. So what do? We have, we do ongoing backups. We do level 1. So there's it's a 40 terabyte data set that we deal with. So now we start doing backups. We do on device, it's on cluster backups. That's our fast backups. Okay, writing full backup sets for security. Where do we do that? We do a set of dailies and we do a set of weekly, and we do dailies and we do some weeklies too. So we will multiply this data set times 4. So we now have 160 terabytes equals 160 terabytes. Wonderful. That's starting to bloat, isn't it? So we also take that as part of our scheme, and we will write those sets to an off cluster array that's geographically different. Oh, our network spans 4 different buildings. So we have the luxury of having physically separated locations to put our offsite backups. We are connected, 3 of the buildings are connected by fiber optic that we buried in the ground, so we've got great connection. The other one is telco fiber that takes us between buildings. So we got fast enough data connections in this to make things work. So we've got 160 terabytes of data. We snapshot ransomware, so your ransomware video, we snapshot a lot. We keep maybe 100 snapshots around or something like that to be able to roll back for periodic, parasitic data destruction. So we got that. What does that take up? I don't have a number for you right now, but it's not huge, and it depends on the rate of change of your data set. If your data set's pretty static, ours is pretty static, it's about deletions. Every time you do a deletion, it doesn't come out of your snapshot set. So you're not releasing blocks back into your unused storage space pool. So you get growth that has to do with how static your data set is. But I'd look at that and I'd say, roughly speaking, I'd say we go up to about 200 terabytes. Interesting how we grew. 10 terabytes and 30 terabytes, all of a sudden we got 40. Let's put some backup sets on there and let's inflate by snapshots. We now have 200 terabytes. But that is not ridiculous, okay? That'll easily fit, okay, that inflated data set. I'm sorry, I have one more inflation. My last inflation is I need to add 50%. Why do I add 50%? Because I'm on a cluster. I have erasure coding. It's just like RAID array. I want some extra storage, and what I end up doing is I have that set. It's like I have 2 servers plus 1 spare. Any one of those can get zapped by a meteorite, blow up and do whatever else, or go down for maintenance. and everything else keeps on chugging. So it costs me 50% extra. So that becomes 300 terabytes that I need. We are still in that zone where we could easily put in a 60 drive machine and we would have 1.2 petabytes. We'd have 4 times that. But we choose to go onto a cluster. We actually have a cluster of 3 15 drive machines is what we use. And why do we go on a cluster? High availability, elasticity. Our people are often creating other storage spaces that are temporary. We have a bunch of research arrays and customer project arrays, storage arrays that we use, but we actually do stuff in our main array every now and then. Somebody says, I got to store some data. So we just have infinite elasticity. We have high availability, and we have, again, I love it, our IT people, they got that whole thing. We like creating enough redundancy in everything so that we reduce the number of emergencies. Really stressful on them, and it's a cost to the rest of the company. So it all works out. That's why I love clusters. We're in that middle zone. If you're on the large data zone, we have customers, we operate some of the, we've helped our customers put together, configured, and in fact, sometimes we actually administer them, some of the largest Ceph clusters in, existence, we believe, from what the Ceph community tells us. And we also have some people with some really small data sets on clusters. We have lots and lots of single servers. Both are wonderful options. I love clusters. Some people love their single servers. I really do love when we get some single servers together and we start playing around single client transfers and just get the data moving so fast. It's great fun. But a little long on my video because I love talking about this stuff. Anyway, you ever want to talk about, love any comments here, anything else, any feedback on what I said today? And if you ever want to talk to us about cluster versus single server, we'd love to talk to you. Thank you very much for tuning in, and thanks for following through this. And I